My name is Kleinlogel. I'm responsible for the battery of Silvretta. It's the new car of the aCentauri solar racing team, and we're here in Darwin right now to participate in the Bridgestone World Solar Challenge 2025. We got a DC-DC converter from Power Integrations, which steps down our battery voltage to 12 volts to power the whole low voltage system in the car. And the DC-DC features the InnoSwitch 3AQ and has been optimized specifically for our load conditions for this race, so that the DC-DC is as efficient as possible at around 46 watts, which is what we need continuous. The DC-DC achieves more than 95% efficiency, which is way more than we ever expected. Also, during charging the car with only the solar deck and everything turned off that we don't need, it still achieves over 93%, which is super good. The DC-DC is also very small and doesn't require any heatsink, which makes it light and easy to fit in our space-optimized battery. Because we don't have much space in our electronics compartment, the size was perfect. We passed static scrutineering first try. The judges didn't have any doubts, and they even admired how clean and organized everything was. That's also because the DC-DC is so easy to integrate, it's easy to organize everything. In the car, we have a high voltage and a low voltage system, and the DC-DC powers the whole low voltage system. This means it's connected to almost all components in the car. So it's connected to the inverter, to the BMS, to the MPPTs, basically to all the boards, and it always powers the control sections of each of these boards. Our low voltage system requires a very large output range. The power we need can go from 5 watts up to even 80 watts if we turn on the lights or honk, for example. So it is really great that the DC-DC can handle this high load and also these super low loads. The Power Integrations DC-DC is mounted in the electronics compartment of our battery, and it is mounted on top of another PCB that we call the PDU PCB. Power Integrations DC-DC is connected on one side to the battery and then on the other to the low voltage system. And we implemented pre-charge logic for both sides on the PCB below the DC-DC. The PDU PCB also implements the safe state loop, which interrupts the output of the DC-DC as soon as an emergency stop button is pressed, and then this shuts the whole low voltage system down, which shuts everything down. Working with Power Integrations was really cool. We had a meeting with the engineers a few months back to talk about our power requirements, and then they optimized the DC-DC for us, and we just got the board a few weeks later. So the whole process was super simple, and because of this we were able to focus on the rest of the car. I'm really looking forward to see the car drive from Darwin to Adelaide, to see all the hard work that we did, that it paid off, and to arrive with the whole team. Yeah, I'm very, very excited for all of this.